Hello everybody. So what we're going to do in this video is take a look at a new special case of right triangles. This one is called a 30, 60, 90 right triangle based on its angle measures. So what we're going to do is learn a new set of rules, kind of like what we did for 45, 45, 90. But in this case, in order to introduce it, what we're going to do is we're going to look at an equilateral triangle. So now we should remember that in all equilateral triangles, the three side lengths are the same and all three angles are 60 degrees. Now, I didn't label this one yet, but it is in fact 60 degrees as well. The reason why I didn't label it yet is what we're going to do is consider half of an equilateral triangle. So if this entire angle was 60 degrees, well, once I draw this perpendicular height here, it's going to bisect 60 into 30 degrees each. Okay, what I want to do is I'm just going to suppose, let's say the perimeter of this whole triangle is 30 feet. So if the perimeter of this whole triangle is 30 feet, then what is the length of each side? So I'm going to take 30 and divide it by 3, and each side is going to be 10 feet long. Right? So I have 10 feet, 10 feet, 10 feet, including the base. However, when I drew that perpendicular height, the base, which is 10 feet, is going to also get bisected. So the 10 feet becomes 2 5 feet. All right? What I'm going to do right now is I'm just going to use half of the equilateral triangle. So that's why I just have this separate diagram drawn over here. What I want you to see is what happens. There's going to be a pattern, just like 45, 45, 90s, where there's going to be a nice shortcut we can take. The only thing now is, if you take a look, I'm going to take my 10 and just kind of translate it over, take my 5, and just copy it down. So if we have a hypotenuse of 10 and half of 10 is 5, I want to see what happens to this third side, which is the one across from 60 degrees. So let me fill in my 30 degrees. I have my 10, I have my 5, and now I'm going to try the Pythagorean theorem. So I'm going to use x, and then thus I'll have x squared plus 5 squared equals 10 squared. And as I go through my steps here, I'm going to have x squared plus 25 equals 100. Therefore, x squared equals 75. All right, and whoops, I'm running out of room here. So what I want to do now is take my square root and find out what my missing side is. So if x equals the square root of 75, we should know by now. Let's simplify that radical. So guys, what would the simplified version of radical 75 be? Well, good. Hopefully you broke it up into 25 times 3, and that's going to give me 5 radical 3. Okay, now let's take a look at the sides here. Whoops, a little too much. So I'm going to have 10, 5, and now 5 radical 3. All right, so let's just leave that there for now. I want to try a second version of this. So I just made up another random 30, 60, 90. However, I want you to notice that in this case, the hypotenuse and the short side, the one across from 30, is half of that. So 10 divided by 5 is 2. All right, so let's keep that in mind. Let's go try another one just like it and see if we can see any comparisons. So again, I have my hypotenuse across from 90 is the biggest side, 8. The shortest side is now half of 8, right? Or divide by 2. Whoops. Or divide by 2. So let's see again what happens if I use the Pythagorean theorem. So let's see. I'm going to have, let's call this x. Let's have x squared plus 4 squared equals 8 squared. So therefore, x squared plus 16 equals 64. I'm going to have x squared equals 48. And then after taking the square root, we have radical 48. Okay? Please take a second right now to go simplify radical 48, and then let's see what you get. Hopefully, we split this up. And it could have taken you a few extra steps here, but we're going to end up getting 4 radical 3. All right, so I'm hoping that we see a pattern. Whoops. I'm hoping that we see a pattern here, okay? In the previous triangle, take a look. We had the hypotenuse of 10 what did we do to 10 to get 5? Right, so we're just going to really cut that in half, right? Divide by 2. But now I want you to notice this last part. If I go from the shortest side to the side across from 60, I'm actually going to multiply by radical 3. So a little different from the 45, 45, 90s, we actually have two parts to our rule. So we're going to divide the hypotenuse in half to get the shortest side, and then we're going to take the shortest side times radical 3 to get, I'll say like the medium side, right? The one that's across from 60. All right, let's see if it works in the next case. Okay, just like what we did down here on the bottom. So, once again, I have a hypotenuse of 8. The shortest side is always going to be across from 30, so what do we do to 8 to get 4? Right, we're going to divide by 2. Oops, that's a little sloppy. We're going to divide by 2. Now that I have the shortest side, I'm going to call this the short leg. How do I get the long leg, the one that's across from 60 degrees? Well, similar to the last example, we're going to multiply by radical 3. And those are going to be our new 30, 60, 90 rules. Okay, next, so what I'd like to do is just generalize what we just talked about. So for in any 30, 60, 90 right triangle, we have to get used to the vocabulary and the terminology. So I used to draw like the little, dude with the flashlight, but what I want us to remember is the shortest angle is, or the smallest angle is always going to be 30, and across from 30 will always be the shortest side. Now, since these two are the legs, we're going to call one of them the short leg, one of them the long leg. But the hypotenuse is always across from 90. All right, so one more time, what do you call the side opposite 30? That's going to be the short leg, and that's going to be X. We'll get to that in a minute. What do you call the side across from 60 degrees? That's always going to be called the long leg, and that's going to get the X radical 3. We'll get to that also in a minute. And the longest side in any right triangle is always the what? Well, that's always going to be the hypotenuse. That's always across from the biggest angle. So what I'd like to do is let's finally get into, and these are the rules, guys. So what I want to do is try a few practice questions. So write these along with me, and we will basically get in a habit here of writing the rules on each figure. So according to what we just saw, there's X across from 30, right? The hypotenuse is always going to be 2X, and the long leg, which is across from 60, is X radical 3 every time. So now check it out. If we look at 8 as X, well, what do you do to make X into 2X? Well, before, we doubled the side length. So now this side is going to be what? 8 times 2 will be 16. All right, right now we're taking our shortcuts instead of using the Pythagorean theorem. Now, if you take a look also, the X side, or 8, in order to change it to the long leg, should turn into X times radical 3. So the rule here is take the short leg and multiply by radical 3. What is 8 times radical 3? That's just going to be 8 radical 3. So guys, that's how we're going to use our 30, 60, 90 rules. Let's try the next one. Okay, now in this case, they give us a different side, but notice it's still the same type of triangle. So I'm going to put my rules on first again. You guys should be writing this with me. So I have X is the short leg across from 30. 2X is always the hypotenuse, right? It's double the size of the little guy. And then across from 60 is always X radical 3. Write your rules each time. So now let's take a look at what to do here. I need to go from the 2X side to the X side. So according to our rules, we're going to divide by 2. So what will be the length of the short leg? Well, it's going to be half of 100, which is 50. What do we do to the short leg to get the long leg? Well, we're going to have to make X into X radical 3. The rule is multiply by radical 3. So what will be the length of the long leg here across from 60? Well, we're going to take 50 times radical 3, and that'll give us 50 radical 3. All right, let's keep it going here. All right, so now in this case, they give us which side? Which is the side across from 60? This is the long leg, right? That's the X radical 3 side. Oh, nice. It does have a radical 3 on it, but we'll get to that in a second. So the side across from 30 is x. The side across from 90, the hypotenuse, is 2x. So guys, this is kind of similar to what we did for the 45, 45, 90s. You know, in this case, take a look. Technically, we can, like you guys said, just get rid of radical 3. But mathematically, what we're doing here is we're taking x radical 3 and dividing by radical 3. So I'm going to go through the motions here, but you guys can definitely take this shortcut from now on. If I have 7 radical 3 divided by radical 3, yes, the radical 3's cancel out, and we just get 7. All right, how do I go from the short leg to the hypotenuse? Well, we're going to take x and make it 2x, or double it. So 7 times 2 gives us 14. Okay. All right, so that's going to bring us to the last one of this little cluster here. Now, guys, this is the tricky one, but as long as you follow your rules, I don't think it's going to be too bad for us with a little bit of practice. So finally, here's what I'm going to say. Always put your rules down. The long leg is always labeled with what? The long leg is always labeled with x radical 3. Across from 30, the short leg is x, hypotenuse 2x. All right, now if you notice right away, this is very similar to what we did with 45, 45, 90. Notice there isn't a radical 3 next to 12 that we can just quote unquote get rid of. So what we're going to do here is we're going to look at our rules, okay? Look at your rules, and it says when we go from x radical 3 to x, we are dividing by radical 3. Now this should bring up some familiar ideas for you guys. Ready? Uh-oh. I have a radical in the denominator. What do we need to do? Well, we're going to need to rationalize our denominator, okay? That's going to give us 12 radical 3 over 3. Which is nice, because 12 divided by 3 will give us what short leg? That's going to give us 4 radical 3. Okay, I told you, this one's just a little tricky, but as long as you follow your rules, it's very similar to 45, 45, 90. Now, guys, let's finish this up. I have x, the short leg. I need to make it 2x, the hypotenuse. So all I have to do is double the short leg. So what is 4 radical 3 doubled? That's going to be 8 radical 3. All right, guys, so just a couple more of these. I just wanted to show you a couple more of the challenging ones, but I can't stress this enough. You know, we're always going to find your short leg first, put an x, hypotenuse, 2x. Although it's not labeled, this angle is 60 degrees, right? And then across from it will be x radical 3. Okay, so as you can see here, I don't have a radical 3, I do have a radical 6. So I'm gonna need to do some calculations. So let's see what happens. So we're gonna go from the x radical 3 to the x side, which means we're gonna divide by radical 3. Now, some people will say, oh, we're gonna have to rationalize here, but I think we're smart enough to recognize, hey, if I can divide the radicals, I should. So what do you think here, guys? What's 4 radical 6 divided by radical 3? That's going to be 4 radical 2. Okay? Now I have my short leg, and I want to go from short leg to hypotenuse, or x to 2x. So what is 4 radical 2 doubled? All right? Now we have our 3 side lengths. All right, on to the next. Guys, you're writing this down, taking notes, pausing the video when you need to. All right, one more time. Here we go. 30 degrees. That's the short leg. So don't be confused here, okay? This is not the x radical 3 side. That's the x side. X radical 3 is always across from 60. So there's your x radical 3. There's your 2x. Be careful. If we want to go from x to x radical 3, we need to multiply by radical 3. So what is 2 radical 3 times radical 3? Well, let's see what happens here. All right, take a second. Let's do some calculations. What would be the long leg? Well, I'm going to have 2 times 3. That's going to end up being 6. Okay? So I have the long leg across from 60. I have the short leg across from 30. And now I want to go from x to 2x, so I'm going to double the short leg. Okay, all right, our final example on this page looks like some questions we will see in our homework. Now, at first glance, I'm looking at this and I'm saying 120 degrees, what is going on here? This looks very different. But if you think about it, we have our equal markers here. So that means this is an isosceles triangle. So what I'd like you to do right now is take a second and go find the measures of these equal base angles. So let's think. So I know that the triangle has 180 degrees in it. So if I subtract 120, that leaves 60. And then we're going to have to split 60 degrees equally. So I get 30 and 30. All right. Now, guys, obviously, this is not one of our special right triangles. However, if I do draw the height here, the perpendicular height, oh, look at that. It's actually going to split this into two side-by-side or adjacent 30, 60, 90s. So guess what I just did here? I split this triangle in half, so guess what happens to 18? That's right. Each of these will be 9. All right? Now, tricky example, I'm just going to clean this up a little bit, all right, just because it gets a little messy. But you should leave your notes on your papers, but this was 30, this was 30. Here was our perpendicular height, and this was 9 and 9. All right, so here we go. To finish up this page, this is the side across from 60. This is the x radical 3 side. This is the x side, and this is the hypotenuse, the 2x. All right, so I'm only going to focus on one side, although the other side is exactly the same thing. So in order to go from the x radical 3 to the x, we need to divide by radical 3. So hopefully you're recognizing right away that I have to rationalize. Whoops. The bottom is radical 3, so that's what I'm multiplying by. So that's going to give me 9 radical 3 over 3, but I can divide that. So that's going to be nice. I'm going to get 3 radical 3 as my height. So guys, going from the short leg to the hypotenuse, or x to 2x, we're going to double. So what is the length of the hypotenuse? It's going to be 6 radical 3. And now I can duplicate the same things on the other side. Okay, on our last page here, I know it looks a little messy, but what I put down was both sets of special right triangles, which we're going to finish up with kind of blending the ideas together. We have to be careful, all right? And I'm going to make sure that we write down the rules each time, but we have 2 sets of ideas now. Now we have 30, 60, 90, and 45, 45, 90. So let's go take a look at this last example together, which will wrap up this idea. It'll finish up our notes. So if you notice, I have a 6 here and a 30, 60, 90 on top. So I'm going to completely ignore the bottom. I'm going to put my 30 degrees here. I'm now going to put my rules in here. Very, very important. Across from 30, what do I write? I'm going to write x. Across from 60, what do I write? X radical 3. And always across from 90, what do I write? 2x. Okay, so now here we go, everybody. This one gets a little messy, but we're going to kind of take a deep breath and just kind of do our thing, right? Write our rules and apply what we know. So if I'm going from x radical 3 to x, I have to divide out the radical 3. So 6 divided by radical 3, we need to rationalize. So let me know, what do you get for this missing side? Well, let's see, radical 3. We're going to get 6 radical 3 over 3, which is 2 radical 3. Okay, guys, what do we do to the short leg to get the hypotenuse? I'm going from x to 2x. So what's your hypotenuse? Well, we're going to multiply by 2 and get 4 radical 3. All right, so we've taken care of the 30, 60, 90 part. Now, here's how we have to remember. Be careful. We have another set of rules. So I'm actually just going to erase, just so I don't get confused. I'm going to erase my rules over here, and I'm going to rewrite my old 45, 45, 90 rules. This was x, and this was x radical 2. Be careful, not radical 3. So now, take a look. The legs in every 45, 45, 90 are always the same. So guess what? That's also going to be 4 radical 3. Finally, what do we do to the legs in a 45, 45, 90 to get the hypotenuse? Well, we multiply by radical 2. So we have to take 4 radical 3 times radical 2. So guys, what do we get? Well, let's see, 4 radical 3 times radical 2. That's going to get us 4 radical 6. All right, so the purpose of this video was to kind of introduce and practice 30, 60, 90, but also help us not forget our 45, 45, 90 rules.